Hi Andy, నేను మీ ప్రియాంక. Welcome to Learning Lens channel. Today we are going to discuss theorem 1.2 in real numbers. So what is this theorem? Let P be a prime number. So assume P as a prime number. And if P divides A square, let A square be any composite number. So if P is going to divide that A square, then P will definitely divide A where A is a positive integer. We need to prove that P divides A. If P divides A square, then we need to prove that P divides A. Okay, let's go for the proof. So what I told, let A be the prime factorization of AB. For what we will write prime factorization? For composite numbers according to the fundamental theorem. Let the prime factorization of AB as follows. Okay, so let A is equal to P1 into P2 into P3 into so on Pn, where P1, P2, P3 so on Pn are not necessarily distinct So what do you mean by distinct? Distinct means different. What do you mean by distinct? Distinct means nothing but different. So they need not to be different. Means there is a chance of becoming same. So not necessarily distinct means it is not necessary to be different. So it maybe there is a chance for the prime numbers to be same. So for this I am taking one example. Let us take 12. So 12 is a composite number. 2 6 are 12 and 2 3 are 6. So in the place of A I am writing 12. So what are the prime factors we got? 2 into 2 into 3. In the place of P1, P2, P3 we got 2 into 2 into 3. In the place of A I wrote 12. So here P1 and P2 are same whereas P3 is different. So according to our condition it is matching. So need not to be distinct. Maybe some prime numbers will match. Okay. So what is the given condition? Given that if P divides A square, then according to the fundamental theorem, P is one of the factor of A. Is it true? Yes. Is it true? How it is? I will explain. Okay. Given that if P divides A square. If P is going to divide this A square, then obviously P will become one of the factor of A. If it is dividing means what? It is nothing but it is a factor. If it is factor only, it will divide. If it is not a factor, it will not divide. So it is a factor, that's why it is dividing. Okay. Let's take an example. Okay. For solving that. And what is A square? A square is A into A. That is P1 into P2 into P3 into so on Pn into P1 into P2 into P3 into so on Pn. So that is P1 square into P2 square into P3 square into so on Pn square. So A square is nothing but P1 square into P2 square into P3 square into so on Pn square. So I am assuming an example for this. So in the place of A square I am writing let A square is equal to P1 into P2 into P1 square into P2 square into P3 square into so on Pn square. Suppose I am taking a composite number. Let it be 2401. So what are the factors for it? 49 into 49. 49 into 49 is nothing but 49 square. Means can I write 49 square in the place of A square? Yes, I can write. So 49 square. So what are the factors for 49? 7 into 7 whole square. So 49 square I am writing as 7 into square means we should write 2 times. 7 into 7 into 7. So how it is? A square is in the form of, so P1 into P2 into P3 into P4. Means what we can tell from this? P1, P2, P3 are the factors of A square. From this we can say that P1, P2, P3 and P4 are the factors of A square. Or factors of A square according to this. Okay. According to this I can say that P1, P2, P3, P4 are the factors of A square. Okay. So what in our given condition it is saying, let P be a prime number if P divides A square. So if P is dividing A square means P is one of the factors of this. So let P be one of the factors among these. So we can assume P as P1, P2 or P3 or P4, any one of these. So we can say that P is one of the factor of P1, P2, P3, P4. So according to the given condition, we are telling that P is also one of the factor of P1, P2, P3, P4. Hence what is given? A is equal to P1 into P2 into P3 into P4 so on Pn. So according to that, P is one of the factor in this. So P is also one of the factor in this. So we can say that P divides A. If it is factor among these, then definitely it will divide A. So hence prove. If a number is divisible by another number, we can say that definitely it is a factor of it. So here P divides A and hence prove. Understood? Okay, next we are going to solve this theorem 1.3, that is root 2 is irrational. So let's find the proof for this. So what is this? Root 2 is irrational. So in order to find the root 2 is irrational, we should assume contradiction, means we should assume the statement as opposite. So what is the as opposite for the irrational? Rational only. So the contradiction for irrational is rational. Meaning of contradiction is opposite. So let us assume root 2 is rational. Let us assume that root 2 is rational. So rational means if a number is rational, it should be in the form of A by B, where B not equal to 0 and A comma B are co-primes. So what do you mean by co-primes? Co-primes means it should have only one as its factors. One as its factor. So no number should be their factor except 1. So let us take 5 and 7. Both are having only the factor as 1. Otherwise 16 and 25. Both will have the factors as 1. So that is the meaning of co-prime. So two numbers that are having the factor as 1. The numbers can be prime or composite, but their factors should be 1. Okay. Next. So we are assuming root 2 as rational. So I am equating root 2 to the rational number, that is A by B, where B is not equal to 0. So squaring on both sides. So what will happen? Root 2 whole square is equal to A by B whole square. So square and root gets cancelled. 2 is equal to A by B whole square. So 2 is equal to A square by B square. So therefore B square is equal to A square by 2. Means 2 is dividing the A square. Means here 2 divides A square. We have discussed in the fundamental theorem, if 2 divides A square, then 2 divides A. In the previous proof, we have discussed that 2 divides A square means 2 divides A. So here 2 is prime number. Here 2 is prime. And therefore 2 divides A. So here I am cross multiplying. 2B square is equal to A square. Let A is equal to 2C. why I am assuming A as 2C and not B as 2C is, here 2 is dividing A and here C is any common integer. Let C is any common integer. C is any common integer. So let us take C value as 1. If you took C value as 1, what happens? A will become 2. So our what we got here is the same. So 2 divides A. And if we took C value as 2, then what we will get? A is equal to 4. So for 4, 2 is one of the factor of 4. So for that reason only I am taking A is equal to 2C, where C is any common integer. So here substitute this A equal to 2C in this equation. 2B square is equal to 2C whole square. So 2B square is equal to 2 square is 4 and C square. So into table 2 ones are 2, 2 twos are 4. B square is equal to 2C square. That implies 2 is dividing B. So if 2 divides B square, according to the fundamental theorem, 2 divides B. So what we got the factor here? 2. So let us take this equation as 2 and this A equation as 1. So from these two, what we understood? 2 is the common factor for both A and B. 2 is the common factor for both A and B. Common factor for both. 2 is common factor for both A and B. But what we have discussed, it should be A and B should be co-primes. For co-primes, 1 should be only the factor. But what we have got here, 2 is the common factor. So we can tell now the assumption is wrong. What we have assumed is wrong. So we can say now root 2 is irrational. Why? Because we got the common factor as 2 and not the 1. So our assumption is wrong and root 2 is irrational. Understand? Today we are going to discuss exercise 1.2 in that first problem. What is the question? Prove that root 5 is irrational. So here we are assuming the contradiction statement. To prove that root 5 is irrational, we are assuming the contradiction statement. So what do you mean by contradiction statement? Means opposite statement. So what is opposite to irrational? Opposite to rational is rational only. So that we are assuming. So let's go to prove that. Okay. Prove. So root 5 is irrational. Let us assume that root 5 is rational. So root 5 is, let us assume that root 5 is rational. So what is the definition of rational number? A number which can be expressed in the form of A by B. So a number which can be expressed in the form of A by B, where B not equal to 0 and A comma B are co-primes, is a rational number. So these are the conditions need to satisfy for a number to be a rational number. What are those? It should be in the form of A by B, where B is not equal to 0 and A comma B are co-primes. Okay. Now what do you mean by co-primes? Co-primes means two numbers are said to be co-prime. So two numbers are said to be co-prime if their common factor is 1. If their common factor is 1. So the numbers can be prime or composite. The numbers can be prime or composite. It may be prime or composite or both prime and composite. So let's take one example. 5 and 16. So these two numbers are co-prime numbers. Why? Because their common factor is 1 only. And take 16 comma 25. So here these both are composite numbers. But why these become co-primes means their common factor is 1. So here look, it is a prime number and it is a composite number. Even though they became co-primes. Why? Because their common factor is 1. Okay, understood? Now let's go into the topic. So both are rational. I am equating root 5 to A by B. So squaring on both sides. So root 5 whole square is equal to A by B whole square. In square root get cancelled. 5 is equal to a square by b square. So what we got here, cross multiplication. I am multiplying this with this. So 5b square is equal to a square. That implies b square is equal to a square by 5. Means what here we observed? 5 divides a. Here 5 divides a. 5 divides a square. So if 5 divides a square, then we can say that 5 divides a from the fundamental theorem. Okay. So let us assume a is equal to 5c. Why we are assuming that if we take c value, any value like 1, 2, 3, 4, anything, it will be multiple of 5 only. So if we take c value as 1, then what it will become? 5 into 1, 5. So c value 2, 5 into 2, 10. So it is a multiple of 5 only. So multiple of 5. So 5 is dividing a square. So multiple of 5 is going to divide a square if we keep any c value. So that's why I am assuming a is equal to 5c and not b is equal to 5c. Okay. So I am assuming a is equal to bc. 5b square is equal to a square. I am taking this statement, 5b square is equal to a square. Okay. 5b square is equal to a square. So in the place of a, I am keeping 5c. 5c whole square. So 5b square is equal to 25c square. So 5 in 5 times. So what we get? B square by 5 is equal to c. So again what we got? 5 divides b square. If 5 divides b square, 5 divides b according to the fundamental theorem. 5 divides b square means 5 divides b. So here 5 is a prime number also. 5 is prime. So let us assume this condition as 1 and this condition as 2. So both a and b here are divisible by 5. Both a and b are divisible by 5. So if both a and b are divisible by 5, means both are having common factor as 5. So they are having common factor as 5. Common factor as 5. Common factor as 5. So common factor as 5. Both a and b are having common factor as 5. So is coprimes will have common factor other than 1? No. Coprime should not have common factor other than 1. So here we got the common factor as 5 and we are assuming a and b as coprimes. So here we are getting the a and b common factor as 5. But what we got here? A and b are coprimes. So these two are not matching because coprimes should have common factor 1. But here what we got is common factor is 5. So both are not matching. Means root 5 is not a rational number. So if root 5 is not a rational number means obviously root 5 is irrational. Not a rational number means opposite to rational number is irrational. So real numbers consist of only two things, rational and irrational. If it is not a rational number, then obviously it will become irrational only. So we can prove that root 5 is irrational, hence proved. Understood? If you have any doubt, please comment me in the text box. Please like, share and subscribe. Next problem. Prove that 3 plus 2 root 5 is irrational. So we are going to solve for that. Okay. So 3 plus 2 root 5 is irrational. So we are assuming here also the contradiction statement. So what is the contradiction for irrational? The contradiction for irrational is rational number only. So let us assume three plus 2 root 5 is rational. 3 plus 2 root 5 is rational. Okay. So 3 plus 2 root 5 is rational. So what is the rational number? Rational number should be, a number can be expressed in the form of a by b, where b not equal to 0 and a comma b are coprimes. Okay, we already know about coprimes. Coprime should have the common factor as 1. It should have common factor as 1. Common factor as 1. So, I am equating 3 plus 2 root 5 to A by B. So, here A by B are coprime numbers. And so, 2 root 5 is equal to A by B minus 3. So, root 5 is equal to A by 2B minus 3 by 2. So, I am into. When it goes to other side will become divide. So, here plus sign is there. So, plus when it goes to other side will become minus. Plus when it goes to other side will become minus. Into when it goes to other side will become division. So, A by 3B minus 3 by 2. So, root 5 is equal to A minus 3 by. So, I am taking 2B as LCM. So, now what we got? So, for 2B LCM, here it is A minus, here 2 only left. So, A minus 3B. Here A, B, 3 and 2 all are integers only. So, here A, B, 3, 2 all are integers or integers. So, integer by integer is rational only. Integer by integer is rational. So, root 5 is a rational. Root 5 is a rational. But it contradicts our statement that root 5 is irrational. It contradicts our statement. It contradicts our statement that root 5 is irrational. So, why we got that contradiction? Why? Because we are assuming the wrong statement. So, it is contradicted. So, root 5 is rational. But according to our statement, root 5 is irrational. Why we got like that is, what we have assumed is incorrect. By this we can say that our assumption is wrong. Our assumption is wrong. Root 5 is 3 plus 2 root 5 is rational. Okay, understood? What is the question? Prove that the following are irrational. We need to prove that the following numbers are irrational. In the third sum, we are going to solve the first problem. What is the question? 1 by root 2. So, let's solve for this. So, we need to prove that 1 by root 2 is irrational. So, we are assuming contradiction means opposite to the irrational. What is the opposite to irrational? Opposite to irrational is rational. So, I am assuming, let us assume 1 by root 2 as rational. So, opposite to irrational is nothing but rational. So, I am assuming 1 by root 2 as rational. So, let us rationalize this 1 by root 2 because the denominator should not contain the root terms. So, 1 root 2 into root 2. So, rationalizing means multiplying with the same number in the numerator and denominator. What is meant by rationalizing? Multiplying the numerator and denominator with the same number. Then what happens? Root 2 by root 2 into root 2. How many root 2s are there? 2 root 2. So, root 2 whole square. And square and root, what will happen? Will cancel each other. Square and root will always cancel each other. So, root 2 by 2. So, what we got here is, in the denominator, we don't have any root value. So, that is called rationalizing. So, let us equate this number to A by B. Why we are equating to A by B? Because we assumed this as rational. I am assuming this 1 by root 2 as rational. That's why I am equating this to A by B. What is rational number? A rational number should be in the form of A by B, where B is not equal to 0 and A comma B are co-primes. So what is meant by co-primes? Co-primes are the numbers that should have common factor as 1. Co-primes are the numbers that are having common factor as 1. So they should have no common factor except 1. Okay? They should have only the common factor as 1. So root 2 by 2 is equal to A by B. That implies 2 is in the denominator. So when it goes to numerator will become into 2A by B. Okay. So what are the two A and B? A and B are nothing but co-prime numbers. A, B, 2. All are integers only. Okay. 2 comma A comma B. All are integers only. So co-prime numbers should be the numbers that can be prime numbers or composite numbers. That will come under whole numbers only. So positive and negative. 2A comma B. Positive, negative and 0 are integers. So 2A, B. These three are all are integers only. So integer by integer is rational. So integer by integer is what? Rational. Integer by integer is, we got what? Rational only. So what we got here, root 2 is rational. But what we have learned in the previous section, root 2 is irrational. We have learned that root 2 is irrational. But here what we got is root 2 is rational. Why we got like that? Because our assumption is wrong. By taking our assumption as wrong, we got the wrong answer. So, according to the rules, root 2 is irrational. But our assumption is wrong. We are taking the wrong assumption. That's why we got the wrong result, that is root 2 is rational. So, therefore our assumption is wrong. Because our assumption wrong, we got root 2 as rational. Our assumption is wrong. Then we can say that 1 by root 2 is irrational. 1 by root 2 is irrational. Okay. We have proved that 1 by root 2 is irrational. What we have assumed that 1 by root 2 as rational is wrong. Clearly we have got that our assumption is wrong. Understood? Okay, next problem. What is the next problem? We need to prove that 7 root 5 also as irrational. So we need to prove here 7 root 5 as irrational. So in order to prove this number as irrational, we are taking the contradiction statement. What is meant by contradiction? Opposite to this statement. What is opposite to irrational? Rational. So by taking this number as rational, we are going to prove that whether this is irrational or rational. So according to the theorem, we are taking the contradiction statement and we are going to prove it. So what we are assuming, let us assume 7 root 5 as rational. I am assuming 7 root 5 as rational. Now what is rational number? Rational number that can be expressed in the form of A by B, where B is not equal to 0 and A comma B are co-primes. So what is rational number? Every rational number should be expressed in this form only. What is that form? A by B. Every rational number should be expressed in this form only. That is A by B, where B is not equal to 0. Means if we take B as 0, what happens? The whole term B becomes infinity. Means here rational term will not exist. For this reason only we should not take B as 0. So B is never should not be equal to 0. And A comma B are co-primes. What are co-primes? Co-primes means the numbers that should have the common factor as 1. The numbers that is having the common factor as 1. So in the name itself it is given. So in the name it is given as co-prime. Means students will think like this. Co-prime means the two numbers should be prime numbers only. No, it's not correct. Their common factor should be one only. Co-prime. In the co-primes, the numbers can be prime numbers or composite numbers. The numbers can be prime or composite, or both primes or both composite. So let us take one example, 7 and 16. So 7 is prime and 16 is composite, even though their common factor is 1 only. So when we write factors for 7 and 16, so their common factor is 1 only. So take another example, 25 and 16. Both are composite numbers only, but their common factor is 1. So co-prime numbers are the numbers which we can take prime or composite or both. Okay. Now let's go to the question. So I am assuming this number as rational. So we have understood what is rational number. So I am equating 7 root 5 to the a by b. Okay, I am equating 7 root 5 to a by b. We already know that root 5 is irrational. So I am keeping only root 5 here and I am taking this 7 to the other side. When 7 is multiplied with other number, it is in multiplied form. So multiplied form when it goes to other side will become division form or it will be denominator. So root 5 is equal to a by 7. Why we are taking the 7 to other side is we already know that root 5 is irrational. That's why we are keeping root 5 here and we are taking 7 to the other side. Okay. So here a, 7, b are integers. So integers will come under rational numbers only. So integers will come under rational numbers only. So in the rational numbers what it will come? So all real numbers is divided into two types, that is rational and irrational. So in the rational numbers only integers will exist. Okay. So a, 7, b are integers. Means if they are integers means it will come under the rational numbers only. So what we got here, this is integer and this is integer. So integer by integer is nothing but rational only. So integer by integer. When we divide integer by integer, what we got is rational number only. So root 5 is rational. So we got here root 5 as rational number. So but according to our rules, what we know that root 5 is irrational. According to rules, root 5 is irrational. So, but we got the answer as root 5 as rational. So, what we got the answer as root 5 as rational is incorrect. So, why we got this incorrect statement? Because of our incorrect assumption. We took the assumption as incorrect. That's why we got the answer as incorrect. Therefore, we can say that 7 root 5 is irrational number. Okay, understood? What is our next question? So we need to prove that the following numbers are irrational. So here 6 plus root 2 should be irrational. We should prove that. Okay. Next we are going to solve that. 6 plus root 2 is irrational. So we are assuming the contradiction statement. What is the contradiction of irrational? Contradiction of irrational is rational. Contradiction means opposite. So opposite to irrational is nothing but rational number only. So let us take 6 plus root 2 as rational number. We are taking 6 plus root 2 as rational number. So what is rational number? Every rational number should be in the form of a by b, where b should not be equal to 0. So if b will become 0, what happens? It will become infinity. So infinity value is not a rational number. And a comma b are co-primes. A comma b should be co-primes. Means a comma b should be in the simplest term. So after division, what the value we got, that value should only be present here, a by b. So a by b are co-primes means that A by B should be in the simplest form or simplest term. Means, let us take here 4 by 8. So, is this in the simplest form? No. 4 ones are 4 and 4 twos are 8. So, that will become 1 by 2. So, 1 by 2 is the simplest form. So, when we look into the simplest form, this is 1 by 2 is simplest form. So, here both 1 and 2 are having the common factor as 1. Both 1 and 2 should have the common factor as 1. So, we should take the numbers when they are in a simple form. For that simple form numbers only we should take the common factors. That is the common factor. So, here after simplifying only we should take the common factors. So, when it is in the simplest form, then we can take the common factors. So, the common factor for 1 and 2 is 1 only. Okay. Now, let's go into the problem. So, what we are assuming? 6 plus root 2 as rational. Means I am writing 6 plus root 2 as rational. That is in the form of A by B. So, I am equating 6 plus root 2 to the A by B. Because we are assuming this as rational. So, what is rational? Rational number is nothing but A by B. So, root 2. Root 2 we know that root 2 is irrational. So, I am keeping only root 2 here and I am taking 6 to the other side. Why? Because we already know that root 2 is irrational. That's why I am keeping root 2 here and I am taking 6 to the other side. So, 6 is in the addition form. So, when it is in addition form, when it goes to other side will become subtraction. Means plus when it goes to other side will become minus. So, root 2 is equal to A by B minus 6. Okay. So, here it is in the fraction form A by B. So, here it is not in a fraction form. So, let's write it as 6 by 1. So, root 2 is equal to B1. LCM of B1 is nothing but B. So, here B is already present. So, we are cross multiplying here. Okay. So, A into 1, A minus B into 6 is 6B. So, now root 2 equal to A minus 6B by B. Root 2 is equal to A minus 6B by B. Now, what are A, B, 6? A, B, 6 are nothing but integers only. So, what are integers? Rational numbers only. Under rational numbers, integers will also come. So, this is nothing but rational number only. Why? Because integers will come under rational numbers only. So, integer by integer is nothing but rational number. So, when we divide integer by integer, what we got is rational number only. So, we got root 2 as rational number. But what happens according to our rules? According to rules, root 2 is irrational number. So, according to our rules, what is that? Root 2 is irrational number. But what we got here? Root 2 as rational number. So, why we got this as wrong statement is, what we have assumed here is wrong. So, because of our wrong assumption only, we got the answer as incorrect. That is root 2 as rational. So, root 2 is not rational according to our rules. Root 2 is irrational number. So, now we have understood that our assumption is wrong. So, our assumption is wrong means, what our assumption is? Our assumption is 6 plus root 2 is rational. So, our assumption is wrong means 6 plus root 2 is rational number. Understood? If you have any doubt, comment me in the text box. Please like, share and subscribe if you like the content. Okay? Thank you.